All right, let's look at a cosine wave. If you're watching this, this is going to be a little bit shorter than the one that I do on sine because I'm not going to go into as much detail as I did there. So if you're looking for a little bit better background, a little more information, watch that one first, then come back here. Okay, so cosine, the function for cosine, again, our input, these are still angles. Okay, the output from a cosine function can be an x coordinate on the unit circle, right? Or it can be an adjacent over hypotenuse ratio on a right triangle. Okay, so keep that in mind. That's what we're looking at. The domain of cosine is the same as sine. It's infinite, so from negative infinity to infinity, and the range also from -1 to 1, just like sine. Okay, again, when we're talking cosine, we're looking at the x coordinates, right? So what is the largest x coordinate that we see on the unit circle? It's 1, and the smallest is -1. So that's why our ranges will fall in there. All right. When we graph cosine and we choose these points, we'll start with 0. And when we take the cosine of a 0 radian angle, what is and we'll focus just on x coordinates here for right now. What are the coordinates, the x coordinate on the unit circle for a 0 radian angle, right? That would be 1. So the output at 0 radians is 1. So for this, our first point in a cosine wave is at its maximum, what we say its maximum displacement. It starts with a max, right? As opposed to sine, which starts at an intercept of the midline. So we're starting up here. As we move to pi over 2, the cosine of pi over 2 is the x coordinate at pi over 2, which is 0. So we're decreasing, right? And think about that for a second, if we could. You know, if you are moving around the unit circle as you move from 0 radians to pi over 2, what's happening to these x coordinates? These x coordinates are close to 1. They're less than 1 because this one right here is 1. These are all less than 1, and they're getting smaller. They're getting closer to the y-axis. Okay, so the x coordinates are decreasing as we move around in that first quadrant. Then when we get to pi, the x coordinate at pi is -1. So we reach the minimum value of -1 when we get to pi radians, which is here. And then as we swing back towards 3 pi over 2, the x coordinate at 3 pi over 2 is 0. And then as we make that full rotation, we end up at 2 pi. So what we get here for this shape, okay, is one period of a cosine wave starting at a max and ending at its max, right? If you want to contrast that, draw this in real quick, but if you want to contrast that with the sine wave, okay, the sine wave starts at the intercept of its midline, goes to its max, comes back to an intercept, down to its min, and then finishes here. So if you're looking at these and you're like, what's the big difference? Can't I just take this and slide it over here and say it's a cosine wave? Yeah, you could talk about a wave. When you recognize a wave on the graph, that wave can be expressed as cosine or sine. It depends on how, how easy or difficult you want to make that task, and we'll do some of that, okay? Just understand that when we talk about, the basic sine wave or a basic cosine wave, a non-transformed cosine wave starts at its maximum, right? So I'm going to get rid of the sine wave that I drew in here because I don't want that to take up too much space or brain power here. But the critical points, we've talked about the critical points before, and that the pattern of the critical points matters for these graphs. For a cosine wave, the critical points start at a max, then go to an intercept, then go to a min, then go to an intercept, and finish at a max. Okay? So max, intercept, min, intercept, max. That's how a cosine wave that's the pattern of one period of a cosine wave. All right? The period is the same. It's still 2 pi, okay? Amplitude, period, phase shift, vertical shift, reflection, all of those characteristics that we discussed about sine waves also apply to cosine waves, Okay, the only difference between a cosine wave and a sine wave is that within that one period length, the critical points go in a different pattern. Okay, so cosine wave starts at a max, intercept min, intercept max. As long as we can keep that straight, we're gonna transform these the same way we transformed sine functions. None of those definitions change. Okay.